So in this video we're going to look at what a function is. So the best place to start when looking at a concept is to define what a function is. So we're going to find a function to be a mathematical relationship where there is exactly one output for each input. So a mathematical relationship is essentially a set of coordinate points. And so we usually write coordinate points in the form x, y. And so the x coordinate we refer to as the input values, and the y coordinate we refer to as the output values. And so when we look at functions, we usually use this notation, this new notation. So this notation tells me when a rule is indeed a function. So we read this as f of x, not f times x, f of x. Let's look at a quick problem. So, say I have, scroll down, say I have this equation, this function, f of x equals, and we're going to say 3x squared minus 7. So, a couple of vocabularies I want to talk about. So, the x value, right? So, in terms of x, we call that the input values. We also call it the independent variable, and the reason for that is because I can put whatever value I want into that spot. Its value is not determined by the y. The y value is the outputs, and we also call it the dependent variable because its value is dependent upon what I plug in for x. Now, y, we also interchange that with f of x in its notation. So f of x is the output I get when I evaluate this function f for an input x. So let's talk about how we can tell if this is a function. So first off, one quick way to do this is to make a table. So let's make a table of x and f of x values. You can name this y. So I usually start looking at a table by using these 5 values. So when I plug -2 into here, I get -2 squared is 4. 4 times 3 is 12. 12 minus 7 is 5. -1. -1 squared is 1. Times 3 is 3. 3 minus 7 is -4. When I plug 0 into here, this term goes away, leaving me with -7. 1, I get a -4 out again because -1 squared and 1 is the same, so the output's the same. And again, just like up here, -2 squared and 2 squared are the same, so I should get the same output, 5. Notice how for each value of x, I only get one output value. So that fits the definition of a function. Let's look at the calculator. So here's a graphing calculator. So I'm going to turn it on. So give me a second to do that. On. Okay. So I'm going to graph this function. So I'm going to go y equals, I'm going to plot 3x squared minus 7. I'm going to graph this. And so you can see how it's a solid curve. Now the way to determine if a graph is a function is with the vertical line test. So if I can draw a vertical line anywhere on this graph and it touches the graph more than once, that graph does not represent a function. So you see how this curves continually to the right and left. There's no point where it just goes straight up and down vertical. So the graph of this function, right, the graph of this relationship passes that test, which means it is a function. So if I didn't know what it was, I can do that. Okay. The other thing we're going to talk about briefly, and we'll discuss in another video, is the concept of domain and range. So the domain we're going to define as the set of possible input values. So you can see in this function, there's no number on the number line I can't square. So my set of possible inputs for this function is everyone. We call that all real numbers. You can see on the graph how this graph is going to go forever in the x positive direction and the negative x direction. And so the graph is telling you also that, hey, any number for x will end up on this graph eventually. The range we're going to define as set of possible output values for the domain items, we're going to say. Now in this graph, we know something about x squared. X squared will always be positive. So no matter what I do, this thing will never, ever, ever get less than negative 7. Because I'm never going to make this negative to subtract from negative 7. So we would say the range of this function would be any number equal to and greater than negative 7. You see how on the calculator, that seems to show me the same thing. I can actually look at the table on this calculator, and I can see how as I go up the calculator, it goes, the graph, the values for x are going down, 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 up, up, up. So you can see how it sort of caresses or has a dip at this value. So my graph, the table, and the calculator showed me that, hey, this graph never goes below y equals negative 7 on this coordinate plane. So it's telling me the same thing. So if you don't understand domain now and range, we'll talk about that in another video. So there's some basic ideas about functions you need to have going forward.